All right, so this is a little tutorial on the gas law practice. That is your homework. If you don't have this open, this screen open, the document open, please go to Classroom and open that. And I'm going to kind of go through this a little bit, the first two for each one. So remember, we've been talking about gases and gas laws. So now you're going to more conceptually apply them in this gas law practice, and then the second part, mathematically actually apply them. So as it says, gas behavior can be explained quantitatively by using kinetic molecular theory. Gas molecules are moving constantly, filling the volume of the container in which they are confined. Collisions between gas molecules and the walls of their container cause gas pressure. So as they hit those walls, it increases the pressure, and you'll see that in the FET. The average kinetic energy of the gas molecules in the container is directly proportional to the Kelvin temperature. Remember, temperature, kinetic energy, and particle movement are all the same. Use these concepts to solve the problems. So you have the three relationships of the three gas laws. So figure out which one applies to each question, and then how would they compare to each other, as in this one. And I will tell you, there are questions like these on the exam. So, at a birthday party, a child sits on a partially filled balloon, decreasing its volume by half. Now notice, I am highlighting when it gives me a measurement and about it, okay? What is the new pressure? So this is my next one. Inside the balloon. So what I see here, if I highlight the measurements that are in this question, I have volume and pressure. And if you look at your three gas laws, the only gas law that has pressure and volume is Boyle's law. And Boyle's law tells you that pressure and volume are indirectly proportional, which means they are opposites. When one goes up, the other goes down. So if I am decreasing the volume by 1/2, then what happens to the pressure? Well, the pressure increases, okay? But notice also that this one gives us a value, okay, of 1/2. Some of them, a lot of them don't. Sometimes you just need to say if it increases or decreases. But this one gives me a value, and I can't. There we go. So pressure increases by, and remember, it's indirect. So what does that mean when we're in math? It means we flip the fraction, right? Indirectly proportional. You're going to flip that fraction. So you're going to flip this 1/2 and you'll get a 2. So it not only is it increasing, but it's the opposite of a half. It's increasing by 2. So you're going to answer these 4 questions. As you notice, the rest of them don't really have numbers, so this part is probably not there, but you're going to have to talk about how this happens. And this one says what condition must be present for the balloon to expand. So think about what has to happen for it to expand. Highlight the measurements, look at your law, and see how it works together. The second page are some calculations, and this is to show you mathematically how it happens. So a little hint, I'm going to do this first one for you, okay? And then I'm going to give you a hint about the second one and on. So when I'm reading these, if I'm doing them on paper, and unfortunately we're here in this digital world, I highlight everything that's in here and I label it. So it says the temperature inside my refrigerator is about 277 Kelvin. So I'm going to highlight that because that is a measurement, okay? If I place a balloon in my fridge that initially, so that's another key little word right there, initially, so I'll highlight that, has a temperature of 295 Kelvin. Okay, there's another measurement. I'm going to highlight that one. And a volume of 0.5 liters. So that's my other one. Okay, so those are our numbers. So what will be the volume of the balloon when it's fully cooled? And this is all volume. So I am going to look at this. And I'm going to see, okay, I have temperature, yes, and I have volume, okay? And probably a huge, huge hint is we give you these up here, okay? So I have temperature and volume. Oops, I changed the text color instead of the highlight. So fix that for a minute. All right, so you have temperature and you have, and I did this to here too, guys. Oh boy. All right, volume. All right, so then I know that I'm going to plug these in, but I need to, as you see, there's two different ways to look at it. It's T1 divided by V1, temperature 1 divided by volume 1 equals temperature 2 divided by volume 2. If you cross multiply, you'll get this one. But now you're just going to plug the numbers in. So I have to decide which one is temperature 1. Well, it says initially. So this one will probably have to be, I'll put them in bold so you guys can see, temperature 1. Okay. So then that means this one, because it's my only other temperature there, has to be temperature 2. Okay. Then I'm going to look at this one, and a volume, well, it's in this initially has temperature of this and a volume of 0.5 liters. Well, since it's still in the sentence that says initially, then this would be my volume 1. So now I have everything labeled, okay? And it says, what will the volume of the balloon be when it is fully cooled by my refrigerator? So it's asking for that second volume. So then I look, I'm going to use this first one up here. I'm going to look here, and I'm going to plug my numbers in. What is temperature 1? Well, temperature 1, as soon as I get this in here, is 295 times volume 2, which is something we do not know what it is, so I'll just put V2, equals temperature 2, which is 277, times, maybe I should put an X. Sometimes you guys like X's. 277 times 0.5. Okay. So now what you will do is go ahead and multiply this out, then divide by 295 to get your answer. Remember, it's just algebra, solving for if this was X. Okay. So that's a little hint. The second one I want you to notice is in Celsius. You will have to convert these to Kelvin. Those are on your gas law notes before you put them into the equation. Then the second one, you have one for Luzak's law. You can use either one. Highlight, plug them in, and Boyle's law. Please make sure you're typing it out like I have at least here so I see what your thinking is. So this is due the next time we meet. So if you have any questions, please let me know.